some of the stuff that we didn't get to the other day. Okay, and we're going to move into some multi-step examples and some dimensional analysis with density. So there's a couple different things you're going to have to look at today. So let's go over these answers and set them up. 5.3 feet tall. That's about how tall I am. So I would diagonal down the feet. The feet need to go down here. I'm going to put the meters that I want on the top. Sometimes people believe that the metric to English are easier because they already provide you with the conversion factor, so you don't have to think of it on your own. So 1 foot, the 1 goes next to the foot. The 0.305, that's going to go next to the meter. Now all I have to do is multiply the top, divide by the bottom, and I will get my answer. The calculator answer here, because remember on these you're not going to get perfect answers, ends up being 1.6165. Now I need to round it to the correct number of significant digits. This number starts with 2 digits, so this number must end with 2 digits. Do I round up to 6 or do I leave it as 6? Leave it as 6. It's 1.6. Do not forget your unit, which would be meter. The feet will cancel with the feet, so you're left with meter, which is what you want. Okay? Now centimeters, 2 kilometers. This one is a metric to metric. Okay? 0.13 km. Set up my chart. Immediately diagonal down that km. Goes down here and put the centimeters up top. Now this one is metric to metric, so you need to do your King Henry. Died by drinking chocolate milk. Now, realizing where you are, we're at kilo and we're at centi of that. Who's the larger unit? Kilo's larger. Kilo gets a 1. Now we're going to count 1, 2, 3, 4, 5. So we're basically taking 10, multiplying by itself 5 times. So 10 times 10 times 10 times 10 times 10. Multiplying the 10 5 times by itself. So it ends up being 100,000. 5 zeros. The one with 5 zeros. Multiply 10 times 10 times 10 times 10 times 10. 5 times. And you end up getting your conversion factor here. So it would be 100,000 centimeters equals 1 kilometer. Let's think about this too in terms of number sense. Does that make sense? If a kilometer is super big and centimeters are tiny and small, wouldn't it take a lot of them to make up a kilometer? Yes, it would take a lot of them to make up a kilometer. Now all you would do here is multiply the top and divide by 1 to get your answer, which ends up being 13,000. These ones are nice and convenient though because you only have 2 sig figs here, and guess what? Your answer already pops up in 2 sig figs, so you do not have to really do any rounding with the metric ones. Kilometers equals, kilometers will cancel with kilometers and you end up with your centimeters here. So do make sure that your diagonals can cancel. They should be able to cancel. What's up on the diagonal should be the same unit each time. Now, for number 6, I'm going to show you a different way to do number 6 where it takes 2 steps. I could have used the answer from number 4 to start number 6, but I'm not going to. Instead, I'm still going to start with my 5.3 feet tall. And we're going to do a multi-step one here instead. So I'm still going to diagonal down my feet. And I'm going to go to meters because I can go to meters. Feet to meters up here. So I'm going to insert that in just like I did before. 1 foot, 0.305 meters. However, I need to get to centimeters. I'm not done yet. So what I'm going to do is add another track. Since I do not want meters, meters is right here. I want to get rid of meters. Now I'm going to take that and diagonal it down over here. Get rid of the meters. Because I want centimeters right here. Okay? So then I'm going to do a second step, a second conversion in the same track. Now, because it is metric to metric, because we have meters and centimeters, meters is a base unit, right? Meters is a base unit. How many hops down to get to centi? 2. That's like 10 times 10. So 1 meter equals 100 centimeters. 1 meter equals 100. 2 hops down. 1, 2, 2 zeros. 10 times 10. Now, the track is bigger. So what do I do with a bigger track? I'm going to multiply everything on the top. I'm going to multiply everything on the bottom. Basically, the bottom's a 1 here. And then I would divide at the very end. So when you have multi-step ones, you have to multiply the top, multiply the bottom, and then divide at the end. Okay, so we have 5.3 times 0.305 times 100, which ends up giving us 161.65. So now I have to make this have 2 significant figures. 1, 2, right? So keep the 1. What do I do to the 6? Leave it alone or round it up? Leave it alone, and then I have to put in for my 1 place a filler 0. Good. That filler 0 in, that's not significant. And we would put centimeters next to it because we don't want to leave our number naked. No naked numbers, they must have their units. These are all measurements, okay? So let's look at number 7. Number 7 is a 1-step. Only does 1 conversion here. And then we're going to revisit some of the multi-step ones on your other page, and then talk some density real quick. Well, if you look here, this is a 1 next to it. So if it's 5 or above, I would have rounded it up to a 7. But since it's a 1, I'm going to leave it as a 6. So that's a good question. All right, so in this case, I need to go from feet to miles. So I'm going to diagonal down my feet. I'm going to go up here to miles, and we use MI for miles because it's easily confused with meter if you just put an M. So 1 mile, because it tells me 1 mile, how many feet is that? 5,280 feet. So basically here, this is a 1-step. Multiply, divide, feet cancel with feet. We end up with miles. And we end up getting 2.5488, whatever. So let's go 1 more out because we have a lot of digits here. How many significant digits in this number? How many sig figs in this number? 5. So we need to keep 5. 1, 2, 3, 4, 5. Do I round up the 8 or leave it an 8? This is a 6 next to it. So I'm going to round it up. I get 2.5489. Don't forget my unit, miles, and circle my answer. So we're going to shift over now to the multi-step ones on the English to metric page. And so get that out. This one that you were working on, we're going to look at 5 through 7. So let's take a look down here on these multi-step ones. 1 through 4, basic 1-steppers, straight out of the textbook. Use your R46 table in the back to figure out the conversion factors. Here, these ones, they don't have a direct conversion. So you can't, from here, can't go from ounces of flour to grams. But in the problem, it tells us we have 16 ounces in a pound. Then we convert it to kilograms. And then lastly, we can convert to grams. So that's going to take us 3 steps to do that. So let's recall from above, what is the conversion factor? I believe it's in number 2 or 3 where you're doing kilograms to pounds. It was 1 kilogram equaled what? What was the value there for kilograms to pounds? What was it? So 1 kilogram equals 0.046 pounds. Good. So 2.2046 pounds. And then from kilograms, we're going to be able to go to grams. So we'll do a King Henry died by drinking chocolate milk at that point. But let's start at the beginning. What is our given information? 6.5 ounces. An ounce is written with an OZ, by the way. Now, where can I go from ounces? It says I can do ounces to pounds, right? Ounces to pounds. So I'm going to do that first. I'm going to take my ounce, I'm going to diagonal it down, and go to pounds. And over here it tells me that 16 ounces equals 1 pound. That's my first step of the multi-step. But am I at grams yet? No, right now I'm at pounds. Like if I finished up, this would be at pounds. So let's keep the track going. I'm going to get rid of pounds now, and I'm going to go to what? What can it tell me? What can I go to from pounds? I can go to kilograms. So I'm going to take my pounds and diagonal that down, put the pounds down here, and go to kilograms. And it told me, you guys told me 1 kilogram equaled 2.2046 pounds, right? 2.2046 pounds. That was from the textbook. Am I to grams yet? No, got to do one more step. This is where it gets lengthy, where there's like 3 steps and 3 conversions in one. I'm going to now take my kilograms, diagonal them down, get rid of them, and go to grams. So now I need to know my King Henry died by drinking chocolate milk. Remember, we're going from metric conversions here. So I have grams. What is grams on that scale? It is a base unit. So it's going to be right here. Grams is going to be at the base unit, B. Here's grams. And then kilograms up here with K, King Henry, right? So who's larger, the kilo or the gram unit? The kilogram, or kilogram, gets the 1 because it's bigger. Now, how many times down do we have to go? 1, 2, 3. So that's like 10 times 10 times 10. So how many zeros? 1,000. So 1,000 grams equals 1 kilogram. Now look at that sizable track. This is where it gets a little confusing. You need to multiply everything on the top. So if you multiply everything on the top, we get 6,500. We need to multiply everything on the bottom. What do we get when we multiply everything on the bottom? 35.2736 or something like that. Now we can do the division. And you're going to get good with the calculators where you're just going to be able to punch it all in and just continue on. So I'm kind of doing it by steps here. So we take 6,500 divided by the 35 answer, and we get 184.27. How many significant figures do I get to keep here? How many sig figs are in our beginning measurement? Beginning measurement had 2, so that's how many I get to keep in my final measurement. 1 and 8. Do I round the 8 up or leave it alone? Leave it alone as I did, and I'm going to add in my filler 0 there in my unit, which is a G. Let's check our labeling, make sure everything cancels. Kilograms cancel with kilograms. Pounds cancels with pounds. Ounces cancels with ounces. And the only thing left here is your gram, which is what we want. Yes? because my answer is 184. So if I don't put the filler 0, then it would just go down to 18. And 18 is not close at all to 184. But 180 is close to 184. So we use that and put the filler 0 in to get the correct rounded significant digit answer. Yes?
Well, are you like a conversion sheet?
No, there is no formula sheet or anything for the SQL, so everything has to be in your brain. All formulas like percent error, density, and there's other ones coming your way. All of that, yes, you have to know on your own.
So that whole like part of the textbook with all the...
We will be giving you review sheets and like I give you practice tests where I give you a cheat sheet to use as you're doing the practice test, but that's to help you recall the information and get it memorized. Okay. You can, if you like, to put your answer here. Some people do. They put their answer right here and they circle it. That's fine. You can put your answer here. That is fine with me. Just circle it so I know that that's your answer.
Could you explain why it's 180?
Yes, because the answer was 184.27 was the calculator answer. Now, I only have 2 significant digits in the beginning measurement. So I get to only keep 2 significant digits in my ending measurement.
Oh, so zeros.
So I keep the 1. I do not round up the 8, but I have to fill in the 1's place with a non-significant 0 because 18 is not close to 184 at all. So I want my numbers to seem reasonable. Okay? Let's try number 6. We're going to do a bunch here before we move on to our physical and chemical properties. So we have 45.90 fluid ounces this time, because fluid ounces are different than regular powder ounces in baking. So we need to go from fluid ounces, a volume measurement, to milliliters. Well, it tells you in the hint, 32 fluid ounces equals a quart. This many quarts equals 1 liter. This is 1 liter. Then change the liters to milliliters. So you'll have to do a King Henry at the end there. So let's diagonal down our fluid ounces. Let's start there. And go to our quarts. QT is quart. So it said there were 32 fluid ounces. That equaled 1 quart. So I'm going to insert my conversion factor. Now from quarts, where can I go? It tells me I can do quarts to liters, so I'm going to do quarts to liters. Now I'm going to take my quart and diagonal it down, get rid of the quart, go to liters. And it tells me that 1.0567 quarts equals 1 liter.
How do you decide which unit to put on top and which unit to put on bottom?
Because whatever's on the top over here is the one that has to diagonal down, because you need to cancel it. Good question. So whatever's on top that you're trying to get rid of should diagonal down because you need to cancel it. Now at liters, we're not there yet. We have to go from liters to milliliters if we go to our King Henry. Where is liters on here? Liters is a base unit. So liters would be right here with the grams. So base unit, and if we're going down to milli, who's larger, liters or milliliters? Liters is larger, so it's going to get the 1, so we put liters down here to milliliters up top. 1. How many hops down? 1, 2, 3. So that's 10 times 10 times 10, which is 1,000. 1,000 milliliters equals 1 liter. There you go. I know sometimes, our brains aren't as fast as our voices. So, and then we get a calculator answer. So multiply the top. On top, we would get over here 45,900. On the bottom, we're going to get 33.8144. Now, once again, if you get good at punching in your calculator, you'll be able to go through that fast. And we end end up with 1357409 something. Now, how many significant digits do we start with over here? How many does this guy have? 4. Good. Has a decimal, so you start from the left when you count. So we need to keep 4 here. So do we round up our 7 or leave it as 7? So we're going to leave it as 7. And we're going to give it milliliters as its unit. And we're going to circle that. Liters cancels with liters. Quarts cancels with quarts. Fluid ounces cancels with fluid ounces. And we are left with our milliliter, as you see. Now I'd like to shift gears real quick and talk about density. I want to show you some examples with how to use density as a conversion factor, because it is something that you need to know for the test, and we've seen it on the SOL before as well. So at the one that says more practice here, this one, go to the back of this page. Go to the back of this page. A couple of things too about these problems. Make sure on number 8 that you realize that calorie is a base unit. It's like meter, liter, or gram on the metric system base units. Same thing here where it says kiloseconds. Okay, kiloseconds, that means that seconds is a base unit. So calories, seconds, joules, all of these can be base units on the metric system. Now what I wanted to show you here is using the dimensional analysis with density example. What is the volume of a metal that has a mass of 87.4 grams and a density of 13.2? Now I did the setup for you, but let me tell you why this works. Density is a derived unit. So when we say 13.2 grams, we're really saying that it's over 1 centimeter cubed. Okay, we don't insert the 1 there, but that means that you, for every 13.2 grams, you have the space of 1 centimeter cubed. So this in and of itself is a conversion factor. So if I start with my 87.4 grams, look what I can do with my grams. I can put grams down here. What can I put on top? If I'm using density as a conversion factor, I can put the volume on top. And then I can just set it up as a quick T-chart, multiply it, divide, the grams cancel with the grams, and I'm left with my volume. Now I'm showing this to you, and there's an example problem number 10 that I want you to try for homework. But here is the volume one. If you start with a volume, starting with like milliliters, you would diagonal down the milliliters, and you put the grams on the top. Okay, and in this particular problem, I did not change the density. It's still 13.2 grams per milliliter. So that means this case, the 1 will go next to the milliliter on the bottom. The 13.2 grams will go on top. Then you just have to multiply it to get your answer. So there's 2 examples of how to use the density as a conversion factor. You can flip it. 1 centimeter on top is going to be 13.2 grams on the bottom. It's a conversion factor that you can insert and use.